Hello, everyone. My name is Larry Sharp. I'm one of the application engineers here at Chroma System Solutions, and I want to thank everybody for joining us today for this presentation we're going to do. It's related to hybrid inverters, and we're also going to include a little bit of information on something called a portable inverter power generator. It's a little new way of cleaning up the output power on a power generator, and it's something that has gained a lot of popularity. So we'll go through both of these devices, what's required to test them. We'll share with you some information on how we're going to offer some of our equipment to help you with those tests, and also any information that we can share with you as far as our history of this equipment and how we can make it easier for you. So let's get started. If you're not familiar with Chroma, Chroma has a wide variety of power test equipment. We're known for being the test equipment globally for power conversion devices. We also include with that electrical safety test equipment and passive component testers such as LCR meters. We've also done unique test equipment related just to battery simulators, battery cyclers, but we also create and take our equipment as well as other manufacturers' equipment and incorporate that into a fully integrated automated test system. We also have created custom software to make the job easier for you and to give you a complete turnkey test system to do the entire test, both for your R&D and your manufacturing requirements, and even for incoming inspection. And if you're a end user of the product and have to do some testing for your product for quality assurance purposes, we also offer the equipment to do that as well. So I'm going to start with hybrid inverters. If you're not familiar with a hybrid inverter, it's a device that can combine renewable energy like solar and combine that with a energy storage system like a battery pack. And it can work both to share the AC output and put it back onto the grid, or it can use it as an off-grid type inverter to drive the local load. It's used a lot in residential. It's also used in some small commercial building usages, but it's also gained popularity with people that are living off-grid completely, and also even recreational vehicles are using it. So if you're not familiar with a hybrid inverter, what it is a combination of a photovoltaic inverter that's typically used to take the DC power of a solar panel or solar array and convert that back into AC power to be either put back onto the grid or to be used locally to drive any of your devices that require AC power. But it has gone beyond that. They've also added the ability to control battery charging and discharging and use the battery to supplement the power from the solar panels when they're not consistently giving you clean power. The other thing nice about this device is, again, it can be used on grid, meaning it can be grid tied, or it can be off grid, meaning a localized load or a complete off grid type of load environment. They also incorporate into its smart interface. Smart interface, if you're familiar with the reference to the smart grid that we talk about a lot, it's a way to control, monitor, and interface your system with the grid and to monitor its operation. And it does it remotely through various interfaces or even wireless. So testing a hybrid inverter is going to require some additional equipment. Because it's a bit unique, it has two independent inputs. It has the input from a battery, and it also has a DC input from a renewable energy source, such as a solar array. And both of these power inputs can be used at different requirements based on which one is giving you the best and maximum amount of power at the time. So solar panels don't always give you a nice consistent condition regulated power. It varies greatly with the irradiation of the sun and other things. Whereas battery power can be more consistent and it can supplement that power whenever there's any kind of differentiation in the output power from your solar panels. And then the hybrid inverter is smart enough to detect which of these is needed at the time and to supply a better and more consistent AC output. And that AC output can then go out to a localized load, or it can go back to the grid. So to test this, you need a way to simulate a solar panel or a solar array. And because they're very unique, we'll go through that in just a moment. We're going to tell you about how we can simulate that with our Chroma 62 100H and 150H solar array simulators. For batteries are also a bit unique. The voltage will decay over time. They have various charging and discharging curves that we'll get into a little bit. And you have to simulate that properly in order to test and verify it with your hybrid inverter, which is also going to act as a battery charger, and it's also going to act as a battery controller to take that power and put it back through and create AC. To simulate the grid, you're going to need an AC source, and the AC source has to be bidirectional, meaning it has to be able to accept the power from the inverter and to put it back onto the grid. And it also needs to act as the grid when the inverter is using that power to possibly go back and charge the batteries. So all of these things combined together is something that Chroma has put together with our R&D group, including a great little digital power meter to tie this all together and to give you even better and more accurate measurements. So when we look at the hybrid inverter functional testing, solar panel, solar simulation is really our 6200 series, H series of DC sources. And the battery simulation or the energy storage system used with your hybrid is going to be our 62 180Ds. They go from 100 volt, 600 volt, all the way up to 1800 volts. So we have a wide range of voltages for those as well. Utility power, we're going to look at using our 61815. It's a new 15 kilowatt AC source that is operational in all four quadrants, meaning it's completely bidirectional and it is perfect as a grid simulator. Our power meter is going to give you extra measurement capabilities, voltage, current, power, efficiency, along with multitude of other measurements, and it gives you great software to incorporate and data log and capture all that information. And we also are going to cover a little bit about standards, because when you're testing, these devices need to be certified. And here's just a few, like UL 1741 if you're a grid-tied device, UL 1699B for the battery portion of it, IEEE 1547 again for grid-tied devices. There's even a part FCC Part 15 Class B talking about harmonic distortion. We're going to cover all these briefly for you, but if you want more detail on any of these products or any of these standards, please reach out to us and we'll be happy to help you with it. So when you, if you're familiar with solar arrays, solar panels, solar cells, they have a very unique way of operating. It's not a regulated output. It doesn't give you a constant output voltage or output current or output power. It varies greatly over the day. As the sun moves across the sky, you're going to get different angles and different levels of irradiation levels. It also can be affected by clouds and shadows, smog, ambient temperature. Solar panels like a lot of sunlight, but they don't like a lot of heat. They prefer the colder environment to be more efficient. So combination of temperature with solar radiation levels will determine how much power you're really going to get out of your solar panels. So when you're testing a hybrid inverter, you need to be able to simulate that characteristic curve that we're showing here in the one graphic. And it shows you that the unit can operate from an open circuit voltage at no load all the way up to a short circuit current. And along that curve, you'll see with the blue curve, which shows power versus voltage, you're going to hit a point where you're going to get your maximum power. And so this is a critical characteristic of a solar array. And with that, we're going to talk about how the inverter tracks to determine maximum power and how that internal circuitry responds to this IV curve. So to be able to test your unit, you have to have a power supply that can truly create this variation in voltage and current and power to simulate an actual solar panel. There's other things that affect it, such as the type of solar cells used to make up the solar panel. They have different characteristics known as a fill factor, and they have different power levels and efficiencies as well. So we'll cover all of these in a little more detail, but I wanted to give you just a brief overview. So if you have any questions, we're going to have people watching the chat room. Please reach out to them. They'll be able to answer your questions while I'm covering it. And also stay on a little later at the end, and we'll be able to answer questions for you and help you out. So our H series, our 62,000H solar array simulator DC source, they come in different ranges, 150 volts up to 1800 volts, power rating from 2 kilowatts to 18 kilowatts. We can parallel all the way up from there to get much higher power levels as needed. Various input ranges, 200, they're three-phase input devices except for the 2 kilowatt unit. And the inputs are 200 all the way up to 480 volts. Select which range you would need when you place the order. They come in a nice compact 3U package, good high power density on the new 18 kilowatt unit. And again, we can parallel these. They have a fast transient response, so they can vary. When the load changes, your output from your solar array voltage is going to change. The higher the current, the lower the voltage, the lower the current, the higher the voltage. So we can transition just like your solar array does based on different load effects, because we actually load the characteristic curve of the solar panel into the firmware in our DC sources so that they will output based on that curve and respond accordingly. It also has various Ethernet, USB, RS-232, GPIB. You can even control it with an analog input if you want to use it for something like hardware in a loop. It's great for that purposes, and we have many customers using it for that purpose for real-time analysis of PV inverters or hybrid inverters as well. We also have the ability to do software for it. We can do real-world weather simulation with our software. And we also have the built-in control for MPP test profiles that meet the EN 50530 European standard. It also meets the Sandia here in the US. The Sandia National Lab have done great studies on how to simulate solar panels and solar arrays. And then, of course, we do the international standards as well. So when you look at our characteristic curve that we talk about how our unit operates, one of the best tools we have to help you with that is our software. We have a solar array simulation soft panel, and with that, you can create the voltage and current curve that we talked about. It also creates the power versus voltage curve, and we can do that and output while operating from the soft panel in real time. And continuously display the maximum power point tracking, you'll see a little red dot here on this display. What that is that's how well your device or the hybrid inverter is staying at maximum power. And it will actually move along the curve depending on how much power you're using by your hybrid inverter or PV inverter. We can also simulate distortions in the curve that are caused by such things as shadows or any kind of cloud covers or weather changes that might affect the efficiency and might affect the way that your solar array or solar panels are actually operating. And we even have a way to simulate the number of panels in your array and what happens if a few of those panels were to drop out or if they were to be various outputs based on different levels of shadows. So if you have any questions about that, reach out to us, and we would love to help you with it. We're very pleased with what our R&D group have done with this particular solar array simulator and how well and easy it is to operate. It has various ways to also control dynamic usage of multiple IV curves. So if you're testing your hybrid inverter to see how it operates under varying conditions from your environmental conditions or the radiation levels of the sun, we have the way to duplicate those and load them and actually walk through or to pace or sequence through these in order to demonstrate how your unit can respond and keep tracking and keep outputting proper power as these things vary over the course of a day, or and we condense it down into a much shorter period of time. So testing the hybrid inverter, we already talked about the overview of it, and I'm going to cover now our 62180Ds, which would be used to simulate the actual batteries in your renewable energy system that would be controlled by your hybrid inverter. So you have to have some way to simulate a battery unless you use an actual battery, which isn't conducive for proper testing. So we've made one of our bidirectional DC sources that has the ability to do battery simulation. So the battery simulator that we have in our 62000D family of products, again, it has a great range of voltages. Our R&D group did a fantastic job putting this together. So you can go from anywhere from 100 volt, 0 to 100 volt, all the way up to 1800 volt outputs. And then power ranges 6, 12, and 18 kilowatts. We can output currents all the way up to 540 amps. And as needed, we can actually parallel more units to give you more power. The efficiency of this unit is incredible. It operates right around typically 93%. And that's as a source or as a load, because this device, being bidirectional, it can output a voltage and drive power to your device when it's acting as a fully charged battery, putting power back into your hybrid inverter. Or it can also act as a depleted battery that requires charging when your battery charging power is coming from your inverter under test and driving back. So because our unit is bidirectional, it can both work as a source or as a load. And again, it has a wide range of input voltages, auto sequencing up to 100 sequences to create various dynamics. It can also do high-speed transient response by switching from being a load as a charging load back to being a load, the source as a charged battery outputting power, and it can do it in fast as 1.5 millisecond transient times. Has a nice touchscreen panel to make it easy to operate manually, but we also have great software with this unit. Comes standard with USB, Ethernet, also has analog input. You can even get optional CAN and GPIB interfaces for it as well. We have this nice little icon that is also displayed on our soft panel. It's the one we show right here that shows load and source. It actually will indicate for you, you can see during operation, what the unit is in, which mode it's in as it's operating. Great display on the front of the unit, clearly readable, even for an old guy like me that wears some crazy glasses from time to time. So battery simulation, it requires more than just a voltage and current and power. When you create and simulate a battery, you have to understand a little bit about the internal workings of a battery. So I've given you this equivalent circuit of a battery. A battery has capacity because it's a charged source of energy. It also has some series inductance and resistance and capacitance, which creates its output impedance, which as you vary the load, the output impedance is going to affect the output voltage of your battery. So there's various terminologies used. There's open circuit voltage, meaning the absolute output voltage of your battery when it's fully charged and when there's no load applied to it. And then there's standard operating or for the operating capacity of it. And so with these type of things, voltage versus state of charge curves, we have the ability to actually take that curve of an actual battery and load that into our software. And then from our software, we can control our 62,000 Ds. So as the load varies, its voltage will vary per that either charging or discharge curve that we've loaded into our software. It's a great device. It truly operates very much like an actual battery. We can even input data, input the internal resistance, equivalent resistance of the battery. So if you have a specification for a specific battery, we can actually duplicate those specifications with our DC source, bidirectional source. This is a look at the soft panel. The soft panel below, it's a LabVIEW executable standalone software package. It's also a nice general user interface for your 62,000D. And with it, we can, as I mentioned, have settings to control what your 100% of your state of charge voltage would be, 0% state of charge voltage, your actual capacity in ampere hours, internal DC resistance. We can also do a curve that gives you the open circuit voltage versus ampere hour capacity file, and also open circuit voltage versus state of charge. So these are the two critical curves that you want to use to truly simulate the actual battery that you might be using with your hybrid inverter. Measurements on this thing are very good. It gives you voltage, current, ampere hours, kilowatt hours for energy, open circuit voltage, DC resistance, state of charge. So all of these things can be measured, captured from the unit itself into the software and shared into a data file. To create those curves that we talked about, it's very simple to do. You can do it from a Excel file, and the Excel file will include the voltage based on state of charge. And those data points can usually be collected from information that you can usually capture from your manufacturer of your battery. So we can truly simulate that actual battery if needed. So testing the hybrid inverter is also going to require that you have the AC output, and that AC output has to be tied either to the grid or supply power back to a standalone or localized load, which might be anything from your TV, washer dryer, hair dryer, you name it. Anything that plugs into the grid is a load to that device. And when it's operating off grid, it has to be able to supply the proper power to those devices for you. So we've got a single device that can handle both of those applications. So our 61800 family of grid simulators can both act as a AC load when you're in standalone or off grid, and it can also operate as an actual grid simulator when you're physically putting power back onto the grid from your hybrid inverter. So again, it's a remarkable little device, gives you all that capability, and with that, we can definitely give you the support you need for any of these tests. One of the test requirements is power line disturbances when you're hooked to the grid. The grid is not perfect either. It has various times when it will have some kind of disturbance to the AC voltage. You need to know how your hybrid inverter output, when it's putting power back on the grid, would respond to various transients or power line disturbances. We have that ability to generate all of the different kinds of power line disturbances that are defined in the IEC 61000-4 standards for susceptibility and immunity for power line disturbances. So by doing that, we've created this incredible software package. So the 61800 family, we've included, it used to be a very large source, and the source started at 30 kVA, went up to 105 kVA, and it was intended for larger applications. But we've included now everything from a 9 kVA to a 15 kVA unit that are actually perfect for the residential and small commercial type of inverters that we're seeing more and more on the market. So with this unit, again, we have software. It operates truly in all four quadrants. So if you're not clear what four quadrant operation is, it means that we can either sync or source power from either the hybrid device, inverter, or we can also use it as an AC load to just be a programmable load to give you some great features for that as well. So I'm going to cover a few of those for you because I don't want to go over on my time. It looks like I'm running a little over right now. But the 61815 has the ability as a regenerative grid simulator to do various types of different amplitudes, waveforms, and timing to create all of these power line disturbances that we had mentioned briefly. And we can go into more detail with this. Reach out to us. We've got tons of information on how to do this, but it includes ability to do sequential changes. As you can see here, what we refer to as list mode. Here we've done a ramp. This is a very over defined type of waveform for just this application, but you can see we ramp the voltage down. We have a dead time where the voltage shuts off. We include some harmonic distortion at a lower voltage level. We go back to a higher voltage level as we actually change the frequency variation, and then we go back to a normal operation. We can also do pulse mode where we do this in small incremental changes. We can do changes as small as a portion of a half cycle is needed. And then we step mode to basically step the voltage up or step it down. And then we have built-in synthesizer, which we can actually create the various waveforms. This one is a harmonically distorted waveform. It has 3 different harmonics that we've loaded, and it creates this very unique harmonic distorted sine wave. The other thing we can do is if you're operating off-grid or not a grid-tied device, as a standalone unit, you have to make sure that your hybrid inverter can drive the loads that it's going to be seeing, loads such as refrigerators, heating and air conditioning, everything from a computer to a small device such as a battery charger for your handheld tools or an electric handheld tool of any type. So a wide variety of loads, and they occur at various incremental times. So you can't always know when you're going to be hit with these types of loads and what the load's going to look like. So our off-grid test for that would still be our 61800 regenerative grid simulator, but we can use it in AC load function. And what we do is we can create a load that will simulate peaks, various peak types of currents, as you can see in the waveforms here, various types of peak currents. We can also do true phase shift between voltage and current to create power factors. When you're driving an inductive load, the current is going to lag behind the voltage. And when you're driving a capacitive load, it's going to lead or be, the current will be before the voltage. So we can truly create that and create power factors all along that range of different types of loading. So it's a great tool for that. And if you need more information on it, please reach out to our sales team. We'll give you information at the end of this presentation. So the grid simulator also, when it's used as a load, has regenerative capability. So when you compare that to a standard load is fully dissipative, meaning any energy it gets from your device is dissipated into heat. Creates a lot of heat, needs a large heat sink or a lot of additional cooling to keep that unit operating properly. The device is going to be much larger. It's going to be 13U or bigger for 15 kilowatts. It's going to weigh a lot more. It's probably going to weigh, 400 or 500 pounds, to be quite honest, in some of these large loads. Whereas our 61815 is fully regenerative. 87% typically of the energy that we're receiving from your device is going to be going right back to the grid. And so only 13% or less of that energy will be dissipated by our unit. And that's why we can make it in a much smaller package. This thing is a 3U package. It's very compact for the power density. It reduces your heat load onto your air conditioning and heating and ventilation system greatly, as you can see in the BTU hour rating. So for a conventional load, you're going to add another 51,000 BTU hours as you operate this unit versus less than 10% of that, or about 10% to about 5.1 kilowatt BTU hours using our new grid simulator, the 61815. The other thing we're going to talk about briefly are the standards. The standards vary greatly internationally. We've put together some brief information for you. If you want this information, there's a lot more than this one slide. I'll be more than happy to supply you more information on this, so please reach out for that. We've also, with our R&D group, they've expanded this to give you a little more detailed information of each of the tests per each of the standards and some of the recommended specifications for those tests. We've also broken it down into a kind of a one-sheet simple explanation of each test within the standard and a little brief description of what that standard expects you to have to do the test, as well as the test specification and what the expected results would be. We have that for a lot of things. This is a rectification charging efficiency test. We also have it for the PCS efficiency test in grid mode and in islanding mode, meaning in grid tied or efficiency when it's operating as a standalone or off-grid device. Standby loss, no load loss, there's tons of these. I don't have time to go through every one, but I'd be happy to share this information with anyone if they reach out to me here at Chroma. And again, you'll see our information at the end, so you can reach out to us. Stabilization currents and stabilization voltage. And then I want to get into this one. This is one of my favorite little devices. It's your power generators have been around for decades. You know, they've been used ever since you know, the 50s we've had, and even before. Back in I believe in the 40s, there were power generators used by the military, and they became very popular after being commercialized. So they're used for a lot of various types of tests, not tests, but power source. It can be used off-grid, definitely. It can be used as a little backup generator when your grid fails. It can be used if you're remotely working a lot of construction sites. You'll see a lot of portable generators out there to use for all of their various tools that they need that run off of AC. So there's a variety of them. There's a number of good units on the market. But the difference with this one is that the standard power generator, it basically gets its output directly from what we refer to as an alternator. The alternator output voltage is regulated by regulating the RPM of the motor. So there's a feedback loop that controls the throttle, that then controls gas to the engine, and it's a very slow response. So your regulation of your output with varying types of loads can vary greatly on a standard generator. It can also vary the frequency, because the frequency is determined also by the pulley system between the alternator and the actual engine that's driving it, and the RPM of the engine. So all of these things play together to make even though it's a nice standard generator, it does have some flaws because it doesn't give you a clean AC output, and it doesn't give you a well-regulated AC output for varying loads, especially for sensitive devices like computers and medical equipment, you name it. The standard power generator would not do a good job for you, whereas the inverter version of the power generator, which includes a inverter taking the AC from the alternator, converting it to DC, and then generating an AC voltage on the output of the inverter. It regulates the voltage, regulates the frequency, is a very low noise output, very low harmonic distortion, perfect for so many different applications. So to test that unit, you're going to need two devices. You're going to need a load in order to load the output of your generator, and you're going to need a load that can vary under different conditions to see how well your inverter regulates when it sees various load changes. You're also going to need possibly a digital power meter to capture that data and to give you good information on how that unit's going to operate. Again, you could use the 61800 regenerative grid AC load as a small 15 kilowatt or below load. And then it would give you those same features that I mentioned before, the ability to run in different modes of operation, to vary the current amplitude peaks, vary the phase angle between the voltage and current to create various power factors. And all of these things are critical when you're testing an inverter, even the inverter internal to a small power generator. So measurement accuracy, we've created this great line of power meters that are incredible for giving you multiple channels. So if you want to measure the input, like on the hybrid inverter, and the output, you can measure DC input power, AC output power, and with our multi-channel 66204 power meter, you get the complete measurement all in one device. We also have a single channel 66200 power meter when you're just testing your power generator inverter output and you need to measure things such as total harmonic distortion, frequency, power, true power, apparent power, reactive power, power factor. All of these things can be measured with these devices, and our R&D again has done a great job on it. They've also, I'm going to skip over because I'm running short on time, but they've also included some great software with these devices that actually even capture the waveforms as well as the measurements. And they can even put in pass and fail data within the software to identify if your unit is operating within a varying tolerance. We also have the ability to measure harmonic distortion. And with the software, you'll be able to capture not only the waveform, but you can also capture each independent harmonic amplitude, as well as display the total harmonic distortion, both for voltage and for current. Another option for this loading that we talked about would be to use our 63800 non-regenerative. It's a device that's been around a while. It's very reliable. It's a little less expensive. So if you're looking for a lower expensive device, I recommend our 63800 AC loads. They come in 1800 watt, 3600 watt, 4500 watt output devices. They vary in voltage from 50 to 350 volts, and they can handle peak currents all the way up to 135 amps. If you need to go higher power, they can also be paralleled. So the AC load, when it gives you the ability also to do various programming. Again, I'm kind of running short on time, so I want to get to the point where I have some time to answer your questions. So thank you all so much for joining us, and I apologize that my time went over just a little, but appreciate everybody for hanging in there and viewing this presentation. Reach out to us. Reach out to our sales team at sales@chromausa.com. You can reach us by phone at 949-600-6400. You can reach me directly, Larry S. at chromausa.com. And you can also reach our apps engineering group at appengr@chromausa.com. So we're going to stay on the line a little longer and answer some questions. We'll be able to answer them through the chat room. If needed, I can open a mic for you from time to time, but it's really difficult when we have this many people joining to open all the mics at once. So please hang in there. Stay with us. We'll answer your questions. And if you can't get to your question today, reach out to us, please, and we'll be happy to answer any question you might have. Also, we're going to make this presentation available online, and we're also going to make this recorded video available for you. And it'll probably be a few days before we get that posted on our website, but keep an eye open for that as well. Again, I want to thank everybody that's helped me. I have so many good people here at Chroma, from our R&D, our sales group, my other apps engineers that helped me greatly, and everybody here that's just incredible. We work as a great team. I feel more like family here than coworkers, but I've always appreciated this group. We have a number of people that can support you. Our service department is incredible. We have the apps engineering group. We have our sales team. We even have our wonderful incorporated, integrated system engineering group that can turn all of our equipment into a complete automated test system. So please don't hesitate to reach out to us. Thank you, and goodbye, and we will stay in touch.